The first one says simplify and state non-permissible values. The catch is the top is a binomial, the bottom is a binomial. Even if there's 12a cubed, it's not the a cubed attached to the 9, it's the 12a cubed attached to the 9a squared. Like they are attached together, right? With brackets around them. When we put brackets around the bottom, it's another binomial. And I say, because it's a plain old rational, what can I take out of the numerator? A 3a squared. My GCF is division. So 12a cubed take out 3a squared is 4a. Minus 9a squared, take out a 3a squared, and I'm left with a 3. And then the 3 and the a squared, because they're a monomial, can go in their own brackets. Then on the bottom, I can take out a 5ab, and then I'm left with 20a squared b divided by 5ab is 4a minus 3. Monomial, monomial, monomial. Now, the catch is, does a 5 get me any non-permissible values? The number 5? No? What about the a and the b? Yes. So your NPVs are a and b cannot equal 0. And then we have 4a minus 3 can't equal 0. 4a can't equal 3 by adding it over. And then I divide by 4. And I get a can't equal 3/4. And a, b can equal 0. Okay, once I state my non-permissible values, then I can cancel off like terms. We agree? So these can go, and this squared and this a can cancel. So I'm left with 3a over 5b. And I say a, b can't equal 0, and a can't equal 3/4. Box. Your test is on Thursday on rationals and polynomials, correct? And tomorrow we'll review polynomials. Is everyone good with that one? Okay, number 2 is monomials all over the place. So I have a 10, I have an x, I have a 4, I have a y, I have a 2, I have a y, and I have a 5. So my denominator only has y can't equal 0. For my restrictions or my NPVs. And then, because it's multiplication, I can draw the line straight through. So the y cancels off the y. And if you're stuck with numbers and you find them hard to cancel, who cares? Cancel them in the next step. So you can cancel the 2, the 4, and the 10, and the 5. Or you could say, hey, that's 20x over 20. And they actually cancel. So I'm just left with x, and then y can't equal 0. So if you don't want to don't want to deal with the numbers as you go along, just multiply them at the end and then reduce. Okay? This one, I have 5 minus 5x. So a lot of people took the 5 out and they were left with 1 minus x. And I'm proud to say that a lot of you spotted that there's something wrong with that. So here I have x plus 1, x minus 1. Before I go to try and cancel anything off, my NPVs are x can't equal plus or minus 1. Okay, now, everyone paying attention? A lot of people noticed that these are the same but wrong signs. Make sure your phones are away. So I have 1 minus x, and this one is positive x minus 1. So are they the same? Not only are they out of order, does order really matter? No, the sign in front matters, right? So this one is a positive x and a positive 1 and a minus x. And this one is a positive x and a minus 1. So wrong signs, correct? So the way I can fix that is by taking a negative 1 out. Or I could have just taken out a negative 5 instead. And then this will become a negative 1, and this will become a positive x. And then they can actually cancel. And so then I'm left with negative 5 over x plus 1. X can't equal plus or minus 1. Now please remember that if you get the same thing but wrong signs, you can just take a negative 1 out and fix it. The order doesn't matter, the signs in front matter. Okay, number 4, I have x minus 3 over 5 times x squared times 25 times x over x cubed times 3 minus x. So my NPVs are going to come from, does 5 give me a non-permissible value? Does 5 give me a non-permissible value? No. X squared and x cubed are just x can't equal 0. And then 3 minus x, I move the x over, so I get 3. Yeah. So, each x can only cancel off one x, right, Nolan?
Yeah.
Yeah. So this x and this x can cross off two x's, the x squared. 3 minus x and x minus 3, are they the same? 3 minus x and x minus 3, are they the same? This is positive x, negative 3, positive 3, negative x. So I could just take a negative 1 out in front, correct? This will become negative x, positive 3, and then they can cancel. So you just take that negative 1 out and it switches the sign so that they match. So if they're the exact same but wrong sign, take a negative 1 out. Then if I'm stuck with numbers, that's fine. I'm going to have negative 25 over 5x cubed. And then I say, hey, I can reduce these. Take out a 5, I'm left with 5. Take out a 5, I'm left with a 1. So I'm actually left with negative 5 over x cubed. X can't equal 0 or 3. Then I have number 5. We're doing 5 and 6 today. We're doing the back side tomorrow at the beginning class to keep some more stuff going. Yep. Okay, so for number 5, the top left, these are all binomials. So I have to either GCF or difference of squares them because currently they don't match anything, right? Nothing can cancel off. So the top left numerator for this one, I get y plus 3, y minus 3. All over the bottom left denominator, I can take out a 2y. And I'm left with 4y squared divided by 2y is 2y. And then negative 10 divided by 2y is negative 5. And then the 2 and the y are monomials, so I'm going to put them in their own brackets. Multiplied by, I can take a y squared out. And then at 2y cubed, take out a y squared is 2y. Minus 5y squared, take out a y squared is minus 5. And in the denominator, I can take out a 3y. 3y squared, take out a 3y is y, minus 1. And then the 3 and the y go in their own brackets. Before I cancel anything off, I have to state non-permissible values. So, does the 2 give me a non-permissible value? No. What about the y? Y can't equal 0. What about the 2y minus 5? I go 2y minus 5 can't equal 0. I get a ton of people telling me y can't equal 5. That's not true. You have to solve it out. So we add our 5 over. And we get 2y can't equal 5. And then I divide by 2. So y can't equal 5 halves, not 5. Totally different. 3 doesn't give me any problems. Y can't be 0 already is done. And then y minus 1 can't equal 0. So y can't equal 1. So those are my 3 non-permissible values. And then anything that cancels in the numerator can cancel in the denominator. I get 2y minus 5, 2y minus 5. The y and the y can cancel off the y squared. And then it doesn't look like much different. So I get y plus 3, y minus 3, over 3, y minus, 6, y minus 1. And then I have y can't equal 0, 1, 5 halves. Number 4 is adding. In order to add, what do I need? Common denominator. Did I give you one?
Yeah.
Do you think on the test you're going to get one with a common denominator? Probably not. So here we get 2x plus 5 can't equal 0. 2x can't equal negative 5 by adding, subtracting it over. And then divide by 2. X can't equal negative 5 halves. So now I have a common denominator, I can write my whole numerator over it. So I get 4x plus 10 over 2x plus 5. Am I done? Am I done?
No.
No, what can I do?
You can put the calculator, right?
Yeah. So you can take a 2 out of the numerator, and we're left with 2x plus 5 over 2x plus 5. They cancel, and I'm left with 2. Guys, paying attention. If my denominator completely cancels, it would be 2 over 1. Do I need to write the 1?
No.
No. So I get 2, and then I'd say x can't equal negative 5 halves. However, what if the question had been like this instead? 2x plus 5 over 2x plus 5. Pretend it was the other way.
Oh, it's 1/2. It's not.
Then it's going to be 1/2. What are these slanted lines? They're just ones, correct? So if the whole numerator cancels off, what am I left with? Nothing? A 1. So remember, if your whole numerator cancels, you are left with a 1 every single time. Please don't tell me it cancels and pick 2. That's not true. A half is not the same as 2. Okay? All right. We're going to finish the second half of this tomorrow. You're going to have some polynomial homework tonight, but I want you to flip to here, the new unit. Yep. Okay. Yeah. Yeah. So we have exponents and logarithms. By the end of this unit, you should be able to do the following. So here are all of our outcomes that you should be able to do, rated from 0 to 5, which obviously right now you can't do any of them because it's brand new. Here's definitions. We'll talk about that after, but not right now. We're going to go to here. So we're going to grade 10. Yeah, back in grade 10. So with grade 10, what we had to do is we had to do exponent laws. And we're going to have to use exponent laws in this unit because it's exponentials and logarithms. Okay? So we're just going to work on exponent laws for today. So when I have x squared times x cubed, first off, I will normally write it like this. Oh, forgot I moved it forward. Okay. I'll normally write it with, well, first off, you have to have an equal sign running down the side because you're simplifying expressions. Remember when you're simplifying something, a left equal sign always goes down the left-hand side? So I would normally write it like this, x squared times x cubed. And the reason why is the multiplication sign looks like an x, right? Do you remember what the rule was? If you have 2 bases and 2 exponents and you multiply them, what do you do with the exponents? Add. So we don't get x to the 6, we get x to the 5. Now why is that? Well, let's think about it. If I have x squared times x cubed, x squared is the same as saying x times x, is it not? And x cubed is the same as saying x times x times x, is it not? So if I multiply them all out, I get x to the 5, don't I? I just have x times x times x times x times x, which is x to the 5, which is why you add and you don't multiply. So 2 bases, 2 exponents, you add the exponents. Okay? Because x times x times x times x times x is x to the 5, not x to the 6. Now we have division. X to the 6 divided by x to the 2. 2 bases, 2 exponents. What do I do them with division? Minus. So it's x to the 6 minus 2, which is actually x to the 4. Now why is that? Well, you could just cancel. X to the 6 is x times x times x times x times x times x. And x to the 2 is x times x. And we'd be left with x to the 4, right? That's the reason why it works that way. That's why subtracting the exponents actually works. C, 1 base, 2 exponents. What do I do now? Multiply. So I actually get x to the what? To the 20. 1 base, 2 exponents, I multiply. What do I do with D if it has that 3 sitting out? Does the 3 only go to the top, or does the 3 have to go to both? Both. So this is an x to the what if it doesn't have an exponent. What is that? An x to the what? 1. Now I have 1 base 2 exponents, right? So this has to go into here and into here. So I'm actually left with x to the 3 over y to the what? 6. What do I have to remember with e? The 3 goes to actually, multiplication is true, but the 3 actually goes to both, doesn't it? This 3 in front has an exponent of what? No. What does it have currently? 1. It has an exponent of 1, doesn't it? If something doesn't have an exponent, its exponent is 1. That's what you do. So we did it here with the x to the 1, correct? You just have to remember that the 3 goes to both of them. The 3 goes to this exponent and to this exponent. So I actually get 3 to the 3, x to the 6. What's 3 to the 3? 27. How do we deal with negative exponents? Does anyone remember? We learned that in grade 10. If your negative exponent is in the denominator and you move it to the numerator, it becomes positive. If your negative exponent is in the numerator and you move it to the denominator, it becomes positive. If you don't believe me, try this. Type this into your calculator. 4 to the negative 1. Type in 4 to the negative 1. .25, we agree? Okay, and this is over 1, because we can put anything over 1, can't we? What's another fraction that equals 0.25? 1/4. Does it not? And that's technically 4 to the 1, is it not? Because anything can be to the 1. And I told you that if you have a negative exponent, if you just move it, if it's in the numerator, you move it to the denominator, it becomes positive. Denominator, move it to the numerator, it becomes positive. So if I move this down here, that 4 to the negative 1 is going to become 4 to the positive 1, isn't it? What's going to be left behind in that numerator? Just a 1, right? So if I have 4 to the negative 1 over 1, and this drops down here, it's going to become 4 to the positive 1, isn't it? And then what's still left up here? Numerators don't just fully cancel. What do you have to leave behind? A 1. So that's why it equals 1/4. That's why it equals 0.25. So if I have x to the negative 3, it's over what currently? 1. When I move it down here, what's it going to become? X to the what? Positive 3. Does my numerator just go away? No. What is your numerator if everything's gone? 1. So these are the same. B, we have two things multiplied, right? So you multiply coefficient, coefficient, and then exponent, exponent, right? Or variable, variable. So here I'm going to go 4 times 2. What's that? 8. And then I technically get x cubed times x to the negative 4. So I get 8x to the what? What do I do when I have 2 bases, 2 exponents? Add them. So what's 3 plus negative 4? This is x to the negative 1. And I often want positive exponents. So this is what screwed people up in grade 10. I haven't taught grade 10 in a very long time, but I still remember because it was painful watching you guys do this. Not you specifically, because I'm not teaching grade 10, but grade 10s. So you only move the object with the negative exponent to the numerator or denominator, correct? So what I would always get on a test, if I gave this question, I would get 1 over 8x to the 1. But some of you are like, yeah, why not? Some of you are like, no. Some of you are like, I have no idea. Okay? What is your 8 actually to? What's exponent is it to? It's to a 1. It's not to the negative 1, is it? It's just to the 1. So does the 8 have to move anywhere? No, it has a positive exponent. The only thing I'm moving to my denominator is this x to the negative 1. Do you see how that negative 1 is not tied to the 8? If it was tied to the 8, it would be 8x in brackets to the negative 1. Is it like that? No. So the only thing I have to move is this x. So I'm going to get 8 over x to the 1. Positive 1, which is technically just 8 over x. Do you see how I did not move the 8? The 8 did not have a negative exponent? Yeah. Yeah. Okay, C. We have to apply that negative exponent through. This 2 is to a 1. It has to go to it as well. So I'm going to get 2 to the what? Negative 3. Times x to the what? Negative 12. 1 base 2 exponents multiply. Now, do both my objects have negative exponents? Yeah. So they're both going to have to move to the denominator. Move down here and make them positive. So I'm going to get 2 to the 3, x to the 12. What's the catch if the whole numerator moves to the denominator? What's left in the numerator? A 1. And then we can actually do 2 to the 3, which is 8, x to the 12. So I have 5x to the negative 3 over 5x to the negative 2. So I'm going to get 5x. What do I do when I have two bases and two exponents and I'm dividing? What do I do with those exponents? I cancel the whole thing. What can I do with the exponents? When you have two bases and two exponents and you're dividing, what do we do? Subtract. So we have negative 3 minus negative 2. What happens when I minus a minus? It's a plus. A negative 3 plus 2. So we get 5x to the what? Negative 1. Do I have to move the 5 to the denominator? Is the 5 negative? No, just the x. So I'm going to be left with 5 over x to the what? What does this say down here? Your turn. What do you suspect I'm going to make you do? It. 1 and 2. Go. Try them out. So this one here, we're going to get a to the 5 times a to the 2, so you get a to the 7. Then we have x to the 8 over x to the 6, which is just x to the 8 minus 6, which is x to the 2. This one we have b with two exponents, so you multiply them, so we'll get b to the 6. This one we have to remember to distribute the 4 through. So we're going to get x to the 4 over 2 to the 4, which is x to the 4. What's 2 to the 4? And then with the 5, we have to remember to distribute it. The 2 is to a 1. People forget to always distribute it to the 2. So we're going to get 2 to the 5, y to the 5, which is 32y to the 5. All right. This one we just want positive exponents. This 4 is positive. It's 4 to the 1. So we're going to get 4 over x to the 3. Just the x moves to the bottom. All right. Then the 15 and the 5, we divide them. So we get 15 divided by 5. These reduce to a 3 over 1. And then y to the negative 3 minus 1. Now some people, so what's y to the negative 3 minus 1? Y to the negative 4. So you're actually going to get 3 over y to the 4. Then with C, we're going to get 3 times 5 is 15, and then we have to add exponents because 2 bases to exponents. So x cubed plus times x to the negative 2 is x to the 1. And then y to the 4 times y to the 1 is y to the 5. So this one, we can take an 8 out of both. This is another way you could do it. I'm just going to show you. So 24 divided by 8 is 3. 16 divided by 8 is 2. And instead of doing the math with negatives, what you could do is actually swap these and make them positive, couldn't we? Could we swap them, the variables? So we could get 3 and a 2. And the p to the negative 3 would move up and become p to the positive 3. And p to the negative 8 could move down and be p to the positive 8. You know what I mean? So you could swap them that way. Because any exponent can move and become negative or positive, moving numerator and denominator. All I did was swap them. And then you have to subtract still. So p to the 3 minus p to the 8 is p to the negative 5. And then where are you going to have to move it? To the bottom. So we get 3 over 2 p to the 5. The good thing is I'm over working with negative exponents. We don't have to deal with them nearly like this. It's a lot easier. But I just wanted to remind you what you learned in 10. Same thing, this just moves up here. So we get 2a to the positive a third. Some people think the 2 needs to move. It doesn't. It's 2 to the 1, it just stays. And this one we have to apply the 3 in first, because we have to do exponents first. So we get 2, and then 2 to the 3, x to the negative 6. So we get 2 times 8, x to the negative 6, which gets me 16, x to the negative 6. And then I just need to bring the x to the negative 6 down. So I get 16 over x to the 6. Okay, I'm handing out a polynomial hand-in. It is not to be handed in and it's not to be marked. We're going through it tomorrow. But it's all practice diploma style. Because you need practice diploma style questions for polynomials. Okay? So what I expect you to complete to tonight is up to multiple choice number 6 and numeric response number 6, which is just the 3rd page. Okay, multiple choice 6, numeric response 6 is what I expect. We're going to go through it right away at the beginning of class, whether you're done or not.